So good morning students. Today I will start your next chapter, acid, bases and salt. Okay. So at first when you eat lemon, orange, what do you feel? It is very sour. It is very sour. So have you think ever that why it is so sour? Or if you have seen in your home that there is soap. If you place the soap or if you rub the soap with the water, then foams are created. Okay, so have you ever think why does this happen? Grapes are sour, okay, and tartaric is also sour. So have you think why it is so sour? Because of acid. Okay, so at first we have to know acid. So what is acid? Before start the acid, I am telling, we know any element or any material consists of large number of molecules, and molecules are consist of large number of elements. Okay, elements means water, and what is the what is the symbol of water? H2O. And why element means water is consist of what? Hydrogen and oxygen. So hydrogen is one element and oxygen is one element. Element means the constituent particles or constituent atom which create the molecule or which create the material. Okay, similarly table salt which we eat, what is that? That is NaCl. It consists of Na and Cl. You know about this term. Iron is also an element. Copper is denoted by Cu, okay, and iron is denoted by Fe. Gold, Au. Silver, Ag. So these are the elements. Hydrogen, oxygen, there is also nitrogen gas in the air, so nitrogen is also an element. Okay, so element means the atoms. Okay, so there are many elements: hydrogen, oxygen, nitrogen, iron, copper, nickel, cobalt, gold, silver. Okay, there are many number of elements, so these are the example, etc. Okay, so what are now what are acid? Acid is what in which one constituent element is hydrogen. One constituent element is hydrogen. Okay, one constituent element is hydrogen. But one thing you remember, it is not that in for every time it is not possible that hydrogen exists means that is acid. That is not possible for every time, but most of the cases or many of the cases when there is a hydrogen, we say that is a acid. Okay, but not for all the cases. Okay, not for all the cases hydrogen, any particle consists of hydrogen means, or any material consists of hydrogen means it is acid. It is not true for every time. Okay, but in many cases hydrogen means hydrogen. If any material consists of hydrogen, then that is acid. Okay, that is called hydrogen. Okay, so if any material consists of hydrogen, that means if any material one of the element is hydrogen, then that is called acid. For example, hydrochloric acid HCl, symbol HCl. So hydrogen chloric acid consists of H and Cl. H means hydrogen and Cl means chlorine. Hydrogen and chlorine. Okay, so understand what is acid. Acid is what in which one element is hydrogen, but this is not true for all the cases, but most of the cases it is true. That's why we say hydrogen means if any material consists of hydrogen, one element is hydrogen, then that is acid. Okay. Another example, sulfuric acid. Sulfuric acid, H2SO4. It consists of HSO. H means hydrogen, S means sulfur, O means oxygen. So sulfuric acid consists of hydrogen, sulfur and oxygen. So one element hydrogen, so it is acid. Okay, another example, nitric acid, HNO3. So it consists of HNO. H means hydrogen, N means nitrogen, O means oxygen. So nitric acid consists of hydrogen, oxygen and nitrogen. Okay, so if any material one of the constituent element is hydrogen, then the material is called acid. So examples are these. Okay, now properties of acid. First property, actually all the acids are, some of the properties are same for all acids. Some of the properties of all the acids are same. So first is acids taste sour. Acid taste sour. First property, which is very important. Acids taste sour. So now we can say when we eat orange, then grapes, we feel sour because we taste sour because in the apple or in the grapes or in the turmeric or in the grape orange, there is acid. Okay, so that's why this fruits taste sour, because it consists of acid, and we know acid taste sour. Okay, so as acid taste sour, so that's why the fruits are tasted sour. Clear? So this is the common property of acid. Okay, due to the acid the fruits are tasted sour. Okay, fruits taste sour due to acid. Okay, and you have to remember some of the example. Apple, in apple there is malic acid, I think. Malic acid, in apple there is malic acid. And orange, lemon, whatever, orange or lemon, there are citric acid. Okay, next apple, orange, and curd, there are lactic acid. Again, what, grapes, there are tartaric acid. Okay, and in insect there is also acid. Okay, in insect there is also acid, formic acid. Okay, but in a bee there is formic acid, but we will discuss it later. So remember this, apple consists of malic acid, orange or lemon consists of citric acid, curd lactic acid, grapes tartaric acid. As acid tastes sour, that's why our fruits taste sour. Okay. So next property, acid dissolves in water. You know what does this mean? Dissolve mean it mixed up. Okay, so acid dissolves in water. Okay, this is the one property of acid dissolve in water. Okay, and if water is added with acid, then a strong acid become dilute. Strong become dilute. If we mix water with acid, then the strong acid become dilute. Strong means, strong, what does this mean? Strong means it is very effective, but dilute means the power is very low. Dilute means power is very low. You see, when we add sugar, when we add sugar in the water, at first it is very low sweeted. The taste is very low sweet. Then we add more sugar and the sweetness become very high. So when sweetness is low, that is called dilute solution. If the sweetness become very high, that is called strong solution. Okay, so dilute means power is very low, strong means very effective, very powerful. Okay, so when acid dissolved in water, and if water is added with acid or acid is mixed with water, then the strong acid become dilute. Strong acid become dilute. That means water dilute the acid. Water dilutes acid. Water dilutes acid. Clear? And if acid or water mixed up, then heat is produced. Remember, if acid mixed with water, then heat is produced. Okay. Next, acids are corrosive. Acids are corrosive. Corrosive means acids wear out the stones, cloths. Okay, so acid has a corrosive property. So that means it corrodes the materials. Acid corrodes the material. It corrodes the material. Like not all material, like cloths, limestones, okay, etc. So acids are corrosive. Okay, next, acid can be strong or weak. Acid can be strong or weak. Acid can be strong or weak. So you have to remember there are two types of acid. First one is strong acid, second one is weak acid. First one is strong acid, second one is weak acid. So strong acid means if our power is very high, weak means very low powerful. Okay, so strong acid example, hydrochloric acid. That's one, hydrochloric acid. Sulfuric acid. Sulfuric acid. Nitric acid. So these are the strong acid. Remember, these are the strong acid. And for weak acid, acetic acid. Acetic acid. Carbonic acid. So these are very low acid. Citric acid, many acid. Okay, in your book it is given, so remember this. I am just giving two examples: acetic acid, carbonic acid. So understand? Okay, now some uses of acid. What are some uses of acid? So nitric acid, nitric acid are used in plastic, photofilm industry. Okay, and again sulfuric acid used in a laboratory, and then fertilization. I mean for in fertilization factory, fertilizers, paints. Hydrochloric acid, it removes rust from the materials. Okay, so there are many uses of acids, so you can read it easily. Okay, so understand what is acids and what are the properties. First property, acid taste sour. Second, acid dissolve in water, and corrosive means wear out the other material. Okay, that means it shorten the material. Okay, it corrodes the material. Okay, like cloths, limestones. Okay, and there are two types of acid. First one is strong acid, second one is weak acid. Strong means very effective, or weak means low powerful or low effective. Hydrochloric acid, sulfuric acid, nitric acid, and weak acid, acetic acid, carbonic acid, etc. Okay. Next base. What is base? So for acid, we know if one of the element is a hydrogen, then we say it is acid. Okay, but if one of the element is oxygen or oxygen with hydrogen, oxygen along with hydrogen, oxygen along with hydrogen, then that is called base. If one of the material is oxygen or oxygen along with hydrogen, then that is called base. For example, and one thing you have to remember, oxygen means the material if any molecule or if any particle consists of oxygen, that is called oxide, and if any molecule consists of any compound consists of oxygen along with hydrogen, that is called, it is called oxide, and it is called hydroxide. Hydrogen, hydro, oxygen, oxide. So hydroxide. Oxygen means oxide, and oxygen along with hydrogen means hydroxide. That means the compound which consists of oxygen, that is called oxide, and the compound which consists of oxygen along with hydrogen, that is called hydroxide. The compound which consists of oxygen, that is called oxide, and the compound which consists of oxygen along with hydrogen, that is called hydroxide. Hydrogen, hydro, oxide, oxide, oxygen, oxide, hydroxide. Okay, okay. For example, sodium hydroxide, sodium hydroxide, NaOH. So you see here one way is Na. Na means sodium. Na means sodium. Remember, Na means sodium. So one element is Na, but see another element, oxygen and hydrogen. So that's why it is called sodium hydroxide, as it is consists of oxygen along with hydrogen. Okay. Next, potassium hydroxide. Potassium hydroxide. So potassium hydroxide means KOH. K means potassium. K means potassium. So potassium, O and H, then oxygen along with hydrogen. So any compound consists of oxygen along with hydrogen, that is called hydroxide. So we can name it easily potassium hydroxide, potassium hydroxide, sodium hydroxide. OH means hydroxide. OH means hydroxide. Okay. Okay, understand? And for oxide example, calcium hydroxide, calcium oxide, calcium oxide. Okay, calcium oxide means CaO. Ca means calcium, Ca means calcium. Okay, Ca means calcium, and O means oxide. So you can name it easily calcium oxide. Calcium oxide. Okay. So you can name it easily. You can name it yourself. If you know this term. Oxygen means oxide. Oxygen along with hydrogen means hydroxide. So that's why potassium hydroxide. Sodium hydroxide. As O and H both are there. But there is only O. O means oxygen. Oxygen means only oxide. So calcium oxide. Okay. Clear? Now properties. There are some properties of bases. So first property, if base reacts with acid, then it gives salt and water. If base reacts with acid, then it gives salt and water. That means if acid plus base is equals to salt and water. So from this you can say easily the definition of salt. What is salt? If acid and base is mixed up, or with the reaction of acid and base, the product is salt. So there is you can say the definition of salt also. So this is the first property of base also. If it reacts with acid, then it gives salt and water. For example, we know HCl hydrochloric acid and NaOH, I said sodium hydroxide is base. So if this is mixed up, then we get NaCl plus H2O, and H2O means water, and NaCl is salt, table salt, which we eat in our daily life. This is table salt. The NaCl, we eat NaCl. The salt which we eat, that is NaCl. Okay, understand? So with the reaction of acid, this is acid and this is base, we get salt and water. Okay, first property. Second property is some of the bases are dissolved. Some of the bases, not all bases, some bases dissolve in water. Some bases dissolve in water. Some bases dissolve in water. Not all, but some bases dissolve in water. And the bases which dissolve in water, that are called alkali. That are called alkali. So remember, the bases which dissolve in water is called or are called alkali. Okay. So when these bases dissolve in water, then we get foam, or that becomes slippery. That's why our soap is slippery. If you mix water with the soap, then what happens? The soap becomes slippery. Why? Because it consists of base. The soap consists of base. Understand? That's why when water is added with the soap, then it becomes slippery. So when alkali is mixed, alkali dissolved with water, then it becomes slippery. Okay. Next, third is, just like some of the acids are corrosive, so some of the bases are corrosive. Some of the bases are corrosive. And one thing remember, for like there are also two types. There are also two types of base. First is strong base, second is weak base. And you know, strong bases are corrosive. Strong bases are corrosive. Okay. So one thing remember, similar for acid. Acid is also two types: strong acid, weak acid. Similarly, there are two types of base: strong base and weak base. And strong bases are corrosive. Okay. Strong bases are corrosive. Understand? Okay. Okay. And NaCl, this is a strong base. There are many, NaOH, it is a strong base. KOH, it's a strong base. Okay. And these are the strong base. And weak base, for example, NH4OH, this is called ammonium hydroxide. Ammonium hydroxide. Ammonium hydroxide is a weak base. So remember this, ammonium hydroxide is a weak base, and strong base NaOH, KOH. NaOH means sodium oxide, KOH means potassium hydroxide. Okay. Okay. And there are some of the uses of bases. Similarly, so you have to remember, sodium hydroxide is used to make in paper factory, soaps. Okay. Potassium hydroxide, it's used in soaps. Okay. Calcium hydroxide, it is used in plaster. And ammonia is manufactured in the fertilizers. Okay. So I hope you can read the uses easily yourself from your book. But you have to remember these properties mainly. And if you remember the property, then you can tell the definition of base, or you can say you can have the clear idea of base. Okay. So understand? Okay. So thank you, students.